Hello guys, this is Wits Lounge, Learning Made Easy, and in today's video we're going to be understanding the concept of relationships between the quantities of measurement in chemistry. Now mind you, an introductory study to stoichiometry has actually been done, and the link to that video is going to be given in the description of this particular video. Do try to look it up before studying this, because it will help you to understand this the more. So let's get into the study. Now, when we consider the relationships between the quantities of measurement, as mentioned in the earlier video, we said that there are four major quantities of measurement. You have mass, volume, number of moles, and number of particles. However, we're going to be looking into the relationships between these quantities. Let's start with the first one, which is the mole to mass relation. Now, the mole to mass relation is actually represented by a straightforward formula, which I will be giving you guys. So we have mole to mass relation, mole to mass relation. The straightforward formula is number of moles equals mass in gram divided by molar mass. This is represented in gram per mole. Number of moles represented in mole. We have earlier stated in the earlier video that whenever you are looking at molar mass, the molar mass is the mass of 1 mole of a substance. So if I'm to represent it symbolically, I will have that the mole to mass relation is N equals mass M over mm. So please do not forget this. To help you understand this, we are going to try out a question. Now you write. The question for this is, what is the number of moles which is found in 2 grams of sodium hydroxide? What is the number of moles which is found in 2 grams of sodium hydroxide? Whenever you're given a question in stoichiometry, there are 2 major things that must be noted. First of all, find what is expected or identify the expected substance, and then secondly, you look out the substance which has a given value. So in our question, we are asked to find the number of moles. So the number of moles of that substance is the expected value, while the value that was given was 2 grams. Now if you notice, we are relating number of moles and mass, and the mole to mass relation is given as N equals mass over molar mass. So the point is, let's get to solve this question. Okay, now to solve it, we have established that N is what we are looking for. The mass in the question is 2 grams, solution. And then the molar mass. The compound involved is sodium hydroxide. So let's find the molar mass of sodium hydroxide. As seen in the question, we have that the molar mass is going to be equals sodium plus oxygen plus hydrogen. What are the atomic masses? 23 plus 16 plus 1. And when you add all this, this is going to give you 40 gram per mole. Okay, so introducing it into our formula, we are looking for the number of moles which is equals mass over molar mass. What would this give us? The number of moles will now be equals the mass of the substance is 2 gram divided by the molar mass of the substance, which we just found is 40. So if we do this, we are going to have 2 over 40, which is 1 over 20, which is eventually going to give us 0.05 moles. And that's that, moles of NaOH. Very simple. So you will notice that whenever you're asked to find the relationship between a particular mass of a substance and its number of moles, you simply represent it by the formula N equals mass over molar mass. Having understood the above example, it is important to note that you can derive the formula to find the mass when you are given the number of moles. Quite simple. Let's look at that. Now, if you are asked to find mass when you are given number of moles, you simply make mass the subject of formula, and that is going to be M is equals N times mm. So for you to understand this, you should have a little understanding of mathematics and proportion. Now, mass is now going to be number of moles multiplied by molar mass. Okay, so let's try out a question to help us understand this. The question is, what is the mass of 0.5 moles of sulfuric acid? What is the mass of 0.5 moles of sulfuric acid? So with that said, let's get to solve this. In this question, you are asked to find the mass and you are given number of moles. Hence, what relation are we seeing? Mass to number of moles. And because we are asked to find the mass, M is going to be equals number of moles times molar mass. That's solution. So the mass, M, is what we are looking for. The number of moles is 0.5 moles. And then we are the molar mass of sulfuric acid of H2SO4 is what we can find down. The hydrogen is 1, but then there are 2 hydrogen atoms, so 1 times 2, plus sulfur is 1, and that is 32, plus oxygen is 16, but then there are 4 of them, so 16 times 4. With that said, we are going to have that the molar mass of H2SO4 is going to be equals 2 plus 32 plus 64, and that is going to give us 98 gram per mole. So let's get to solve, which means that because we are looking for the mass, it is going to be number of moles is 0.5 moles multiplied by the molar mass, which is 98, and when you do that, you are going to have 49 grams as your answer. And that is quite simple. So you find out that whenever you are relating the mass to number of moles, you simply use the formula N equals mass over molar mass, or M equals N times molar mass. That is that about mass to mole relation. We'll go to the next relation, which is mole to volume relation. The number of moles and volume are related by a simple formula, which is equals N equals volume. Okay, let's use the actual terms. Let's use number of moles equals volume all over molar volume. Now, in our earlier video, we were able to establish that molar volume can either be 22.4 dm cube or molar volume is 22,400 cm cube. The usage of this particular molar volume is dependent on if the volume is in dm cube or if the volume is in cm cube. So let's get to work. Now, in a scenario where you are asked to relate number of moles and volume in cm cube, it's going to be volume in cm cube divided by the molar volume we are going to use is the molar volume that has cm cube. Okay, no, this is dm cube per mole. This is also cm cube per mole. So this is going to be 22,400 cm cube per mole. Now, if we are asked to relate the number of moles and volume in dm cube, it is going to be quite simple. Volume in dm cube divided by 22.4 dm cube per mole. So you have that straightforward formulas. Where you have number of moles and volume to be related, it is going to be N equals volume in cm cube divided by 22,400 cm cube per mole, or N equals volume in dm cube divided by 22.4 dm cube per mole. Let's get into questions to understand this. The volume of 2.5 moles of oxygen at STP is equals dash. So let's get to solve this question. So you notice that you are given number of moles and asked to find volume. First of all, the relationship between mole and number of mole is established by N is equals V in dm cube all over 22.4 dm cube per mole. Now, if we happen to make the volume subject of formula, the volume is going to be volume in dm cube equals number of moles multiplied by 22.4 dm cube per mole. So let's get to work. Now, we were asked to find the volume in this question, whereas we are given the number of moles. So we are asked to find the volume. Let's find the volume in dm cube. N is equals 2.5 moles. And yeah, the molar volume remains constant. So let's get to work. It means that the volume in dm cube is simply going to be equals 2.5 multiplied by 22.4 dm cube per mole. When you do this, you are going to have 56 dm cube. So you have that. Very simple. So in this question, we are asked to find the volume that is contained in 2.5 moles of oxygen, and the answer is 56 dm cube of oxygen. Okay, let's try one more question to help you understand this. The second question we are going to be considering to help us understand this is, what is the number of moles contained in 112 cm cube of chlorine gas at STP? So we get to solve. Now, because we are dealing with volume in cm cube, we are going to be using the formula N is equals volume in cm cube. Instead of using the molar volume of 22.4 dm cube, we are going to use 22,400 cm cube per mole. Okay, so having said that, we get to solve. So N is what we are looking for. The volume in cm cube was given as 112 cm cube, and then our molar volume remains constant. Now, which is going to leave us as N is equals the volume in cm cube is 112 cm cube divided by 22,400. And if you do that, you are going to have 0.005 moles. And that's that, moles of chlorine gas. So you have that, quite simple to understand. So please have in mind that there are straightforward formulas to solve this thing. To relate number of moles and volume, it is given as N equals V in cm cube all over 22400, or N equals V in dm cube all over 22.4. In a scenario where you are now looking for the volume, you simply make the volume subject of formula. V in dm cube would be equals number of moles times 22.4, while V in cm cube would be equals number of moles times 22,400. Thanks for watching this video. Do note that the link to other parts of this study will be found in the description of this video.